Hello, everyone. Good afternoon or good morning, wherever you are. Welcome to today's very special T&D World webinar entitled Champlain Hudson Power Express, a renewable energy solution for New York City. And it is sponsored by Power Delivery Intelligence Initiative and Transmission Developers, Inc., or TDI. We have 4 experts in engineering and project development from TDI USA Holdings who are directly involved with this completely unique and critical Champlain Hudson Power Express transmission line project, which will bring clean energy and hydro from Quebec, Canada to the Big Apple. They call it the most powerful project you'll never see, with more than 300 miles of line, either under waterways or underground. And it is expected to be completed and operational by 2016, I believe. I'm Rod Walton, Managing Editor at Microgrid Knowledge and EnergyTech.com, representing T&D World, your host for today's event. We are all part of Endeavor Business Media. Before I introduce our panel today, let me go over a few housekeeping items on how you can participate in today's presentation in the most seamless way possible. First, if you're having any technical difficulties during today's session, please just click on the questions icon window that you see on the side of your screen and type in your problem, and our technical expert will help you out. We recommend disable any pop-up blocking software or extensions that you have in your browsers, as this can cause issues with the webinar player. Additionally, we welcome your questions during today's event. Our panel will answer as many questions as possible in the Q&A portion that follows the main presentation, but please feel free to send them in at any time. To do so, just find that questions icon, type in your question, hit submit, and you're in the queue. Also, please be aware that today's session is being recorded and will be available on the T&D World website, that's tdworld.com, within the next 24 hours. You'll be notified by email when that archive is available. And you'll likely want to see this again, and you'll want to share it with colleagues. This high voltage, direct current, and underground line is truly something special in the U.S. these days. Now, our 4 project experts from TDI include Robert Harrison, Senior Vice President of Engineering for TDI USA Holdings. We have Sabrina Taylor, Senior Project Manager with TDI USA. Stephen Rutke, who is Vice President Project Services for TDI. And Michael Main, Director Engineering Services at TDI. And bringing it all together as only he can is Mike Beeler, who is National Spokesperson for the Power Delivery Intelligence Initiative and our moderator for today's webinar. And with that, welcome to you all, and the floor is yours.
All right, Rod, thank you very much. This is Mike Beeler, and it's a real pleasure to be here. This is going to be a great webinar, and we are going to go through about 30 to 40 minutes of presentation with the last 15 to 20 minutes of questions from the audience. So the Power Delivery Intelligence Initiative is a group of contractors and consultants and cable manufacturers and people involved in advocating for underground versus overhead. We want planners and engineers and data scientists today to look at the total cost of ownership of underground versus overhead over the life of the asset. So this is one of the most interesting and complex underground and submarine projects currently going on in the country. We're really thrilled to have the team from TDI here today. So Rod introduced the speakers to you. I think what we're going to do, speakers, Bob, we're just going to go directly to you. You've got a lot of rich information to present to us. And so, Bob Harrison, why don't you take it away with your team and give us your presentation today?
Sure. Hey, good afternoon and good morning, everybody. First, I want to thank the Power Delivery Intelligence Initiative and T&D World Magazine for giving us the opportunity to share this project with you. As you've heard, there's a lot of superlatives associated with this project, and I think we should get started. So, if I look at the project on a page, this is a great slide for that. As you can see, it's 60% in waterways, 40% buried underground. Key points here are it's 1,250 megawatts, 10.4 terawatt hour, carbon-free energy from Quebec to New York City. This will supply up to 20% of New York City's peak demand, depending on time of year. It's a merchant transmission project that was selected by NYSERDA in a Tier 4 renewable solicitation. We'll discuss the regulatory and the environmental and economic benefits later on, but this is a great slide just to have a look at the way things, the project in a nutshell. So moving on, why is it underground? Well, there's a lot of issues associated with extreme weather events that could impact overhead lines. The difference here is that the generation source is geographically distinct from the consumption, so it's less likely to experience coinciding extreme weather conditions. The hydropower from Quebec is fully dispatchable renewable energy, dispatchable 24/7, and the fact that it's buried, safe, and resilient, and with black start capabilities can really help New York City restart from a significant outage. So you heard the term before, the most powerful project you'll never see, and here it is laid out for you. So first, some terminology. The portion in Canada is known in Quebec as the Hertel-New York Interconnection Project. About 36 miles from the converter station at the Hertel substation. Most of that is underground, with the exception of about the last mile before the Canadian border is in the Richelieu River, which is essentially Lake Champlain on the U.S. side. It will be owned, operated, and maintained by Hydro-Quebec on the Canadian side. The Champlain Hudson Power Express, also known as CHIPPY, is the U.S. portion of the transmission system, about 339 miles from the border to Astoria, Queens, owned, operated, and maintained by CHPE LLC. And if you take a look at the diagram there, you see we come down Lake Champlain for about 97 miles, and then we come on land, and the purpose is to get ourselves to the Hudson River. We're actually on land further than we would have originally liked, but there were some legacy contamination issues in the Hudson River, which kind of pushed us further south before we get into the river. And then you see also we come briefly out of the Hudson in Rockland County. There you see Stony Point to Clarkstown in the picture. That's about 8 miles because we're bypassing Haverstraw Bay, which is a endangered Atlantic sturgeon breeding ground. So we had to leave the river in that area, bypass it, and then go back into the Hudson River and then to the Harlem River, and eventually a horizontal directional drill under the East River and into the Astoria complex, which is where our converter station is located. In terms of the numbers, we're talking about, of the 339 miles, you've got about 193 miles submarine route in 3 bodies of water, as I discussed, Lake Champlain, the Hudson River, and the Harlem River. The terrestrial route is about 146 miles, the vast majority of which is in existing railroad rights-of-way. The rest is in New York State, county, and municipal roads, and then a small portion is in CHP-controlled property where we secured easements or outright bought property to place the line on. What technology are we using? So, not surprising, it is XLPE cable, solid dielectric, no fluid, proven technology, about 5-inch diameter cables. The fact that it's DC is for 2 reasons. Number one is because we are connecting 2 asynchronous grids, that being Quebec and the New York ISO. With DC over extended distances, losses are lower than in AC. As far as the converter technology, we're looking at a VSC provided by Hitachi. Again, proven technology. It's been around a long time, and realize that the using proven technology is extremely important on a merchant type transmission project that is being privately financed. We had to go to the debt markets to borrow about $6 billion. So the bankers wanted to make very sure that we were using a proven technology. Moving on, the regulatory aspects. The permitting process, as you can imagine, was significant. U.S. Department of Energy Environmental Impact Statement, a presidential permit, a New York State Article 7 certificate, New York State Water Quality Certificate, U.S. Army Corps of Engineers. What's really kind of unique here is the presidential permit, which is required when you are transmitting energy across the international border. And interestingly enough, in order to get that presidential permit, you have to get buy-ins from the U.S. Department of State to address any diplomatic issues, and the U.S. Department of Defense to address any potential defense-related issues, in addition to additional authorizations from the National Marine Fisheries, U.S. Fish and Wildlife, and as I said, the U.S. Army Corps has been very involved in the project. The project has very wide and broad support. And why is that? There's two reasons for that. Number one is because of the benefits that the project brings in terms of decreased wholesale electricity costs, generation of new economic output, reduction in carbon dioxide emissions, $1.4 billion in new tax revenue to the communities that we pass through over the first 25 years, as well as about 1,400 new construction-related jobs as we build this project over time. So those are the economic benefits, and then there's got to be some other community benefits as well for obtaining the support we need. And what you see on this slide is some funds that we have put forth to address concerns of the communities that we're passing through. So a green economy fund to support residents living in disadvantaged and frontline communities, $117 million for restoration and enhancement of the Hudson River and Lake Champlain habitats, $33 million for the Haverstraw Bay Fund, and $9 million in community engagement funds to address frontline residents with a focus on education, climate, and jobs. So you can see it's not just an engineering project. There's a whole lot more behind it. So as we move forward now, on the regulatory standpoint, in New York State, there's something called the EM&CP process, which is Environmental Management and Construction Plan. So what you see there on that diagram is we've broken the project up into a number of submarine and terrestrial segments. And the EM&CP plan is basically the detailed design along with demonstration of consultation with communities, studies that may be required, and all these are necessary to demonstrate to the New York State Department, the New York State Public Service Commission that this is in the state's interest to go forward. So we've broken it up into about 20 or 25 segments. Each segment has to be approved individually by the state so that behooves you for a project of this magnitude to break it up into manageable details, because you cannot begin construction until you get the EM&CP approved by the state and then get a notice to proceed. So by breaking it up into that many segments, it allows us to move forward with the project before we've gotten all of the segments approved. So that kind of gives you a flavor. And now to get into more details, I'd like to turn it over to Sabrina Taylor, who is overseeing a significant portion of the submarine installation. Sabrina?
Thanks, Bob. Hi, everyone. Like Bob said, my name is Sabrina Taylor. I'm the Senior Project Manager for the Hudson River Marine installation of the Chippy project. I wanted to initially take an opportunity to show how we're kind of broken down with our contractors. So Chippy is the project. Our EPC marine installation contractor is NKT. And Caldwell Marine, looking at Caldwell Marine specifically, they'll be focused on the Lake Champlain and Harlem River installation. Caldwell Marine International is a New Jersey-based marine construction company that specializes in offshore cable installation and heavy civil marine construction. They'll also be performing all of the transitional HGDs. We'll have 4 for the marine installation, and that's where the cable will transition from land to marine or vice versa. Looking at the Hudson River install, we've hired an outfit called ASSO Subsea. They're a Greek outfit, and they're a leading contractor in offshore cable installation projects for both land and subsea cable installation works. Currently a turnkey installation vessel with the same capabilities as ASSO and other installation companies does not yet exist in the United States of America. They specifically specialize in submarine cable installation, protection, repair, and support operations, and they have a long track record of successful project execution, and they also have highly customizable equipment. The last contractor I want to talk about is Deep Ocean, who will be performing the mattressing installation in the Hudson River as well. Deep Ocean are capable of providing other subsea services for global offshore industries. They can provide installation maintenance, repair, and they also do subsea construction and cable lay. But like I said, we'll only be using them for mattressing operations. We're working with a Houston-based construction team with Deep Ocean, and they're operating an American flag vessel owned by a company called Hornbeck, who's out of Louisiana. This is an overview of the submarine route. So looking at the far left with Lake Champlain, the Lake Champlain installation is roughly 97 miles from the Canadian border to Putnam Station, New York. All the works in Lake Champlain are currently scheduled to be completed during 2024, and that'll include the pre-lay mattressing, pre-lay grapnel runs, cable installation, and post-lay mattressing. As we go through in the presentation, I'll describe some of those activities a little more in detail. Looking at the Hudson River installation, it's roughly 89 miles that will be completed in 2 discrete campaigns. The first campaign, we refer to it as the Upper Hudson, and it's roughly 68 miles, and that will be completed in 2024. The second campaign is the Lower Hudson, and that will be completed in 2025. All of the pre-lay mattressing will be completed this year, and the pre-lay grapnel, cable installation, and post-lay mattressing will occur during their respective campaign years for the 2 sections. Looking at the far right, the Harlem River is roughly 6.5 miles and will run from Spuyten Duyvil to a bulkhead penetration in Bronx County, New York. The bulkhead penetration and pre-lay mattressing are scheduled for this year, and the cable lay and post-lay mattressing are scheduled to be completed in 2025. So going a little more in depth with our capabilities, first talking about our subcontractor, Deep Ocean. To highlight what concrete mattresses are, they're articulated concrete pads, and they're used in industry to protect co-located infrastructure such as telecommunication lines, electrical lines, or gas lines that are already placed on the riverbed or underneath the riverbed. And we'll also use them for our submarine cable where burial depth is not achieved. Concrete mattress technology was developed by the U.S. Army Corps of Engineers, and it was originally used as an attempt to stop erosion on the banks of the Mississippi River. It's now the industry standard for protection of submarine infrastructure, and that's including offshore wind and other cable installation projects. Deep Ocean performed their initial campaign from the end of March into early April of this year. They utilized a crane and a diverless mattress frame, which is outfitted similar to ROV for precise movements. So on the bottom left, you'll see the Haas Bayou, which is the vessel that we used. And this photo was actually during the cable installation campaign. And then in the top right, that is the diverless mattress frame in the shop. The mattress frame is attached to polypropylene loops that are at the edge of the mattresses, and those are placed precisely over the infrastructure, primarily using sonar imaging due to the lack of visibility in the Hudson. The Haas Bayou specifically is a 302-foot DP2 vessel. DP2 just speaks to the class, and basically there's increased redundancy on the vessel. In case there's a failure mode, we won't lose our positioning and we'll still be able to install precisely. I really like this photo. I think I might have mentioned this, but it was taken during the eclipse, and I just think it really highlights, you know, kind of the cool operations that we're doing. So if you also look at the two bottom right photos, the first one shows the diverless mattress frame before it picks up a mattress from the mattress stack. And then the second one is as the mattress is being placed into the water. Looking at ASSO Subsea, so the Ariadne and the Atalante are also DP2 vessels, and they will be completing installation that's called, it's referred to in industry as simultaneous lay and burial, and that will be using a jet plow. The jet plow is specifically designed with an adjustable blade that rests at the bottom of the river, and it's towed by the vessel. The plow will create a narrow trench at the depth that we designate, and the water jets on the front of the plow will actually fluidize the settlement within the trench. The cable will be fed through the plow and is laid into the trench as it moves forward, and the fluidized sediments will settle back into the trench and bury the cable. The Atalante will complete the first batch of cable installation, which is roughly 36,000 meters, and was selected mainly due to her ability to operate in shallower water depths. The Ariadne will complete the next two batches in the upper Hudson and will return in 2025 to complete the single batch in the lower Hudson. The Estrella is a support vessel that we'll use to deploy what's called the remedial burial tool. The RBT will be used in areas anywhere where required burial depth is not achieved during simultaneous lay and burial. It operates similar to an ROV using tracks, and it has jet swords that will be placed around the cable to further fluidize the existing soils and lower the cable to greater depths. Looking at
Sabrina, it's Mike Beeler. Just a really quick question. What is the burial depth? What is the burial depth?
So the required burial depth in the Hudson River specifically is 7 feet, unless we're in the federally maintained navigation channel, at which point the burial depth required will be 9 feet. Lake Champlain, I believe, is 5 feet, and I do apologize. I'm very focused on my own scope, and I'm trying to give a broad overview, but I believe it's 5 foot burial depth in water depths of less than 150 feet.
Great, thank you. That was a question from the audience that I thought was important.
Yep, absolutely. So looking to the Lake Champlain installation and CMI, the Lake Champlain installation will be performed by barges that have been fabricated to perform this work. The top photo is a digital rendering of the barge configuration pre-construction, and the bottom right photo is actually a picture of the barge that was built and is currently at the quayside in Lake Champlain. The cable will be buried in water depths less than 150 feet, and then in areas where the water depths are greater than 150 feet, an articulated pipe protection that's going to be similar to the images in the top right will be utilized. Euroguard and Euroduct are common brands of the articulated pipe protection. Lake Champlain will also utilize the jet plow technology to achieve burial depths similar to the installation methodology in the Hudson River. And Lake Champlain will be installed in 8 segments. Then to just round this out, there are a number of steps that need to be taken, both operationally and administratively, before we actually can do our cable installation campaign. Just to highlight some of those things that we need to do before our installation is the transitional horizontal directional drills and complete preparations for cable pulling and landing in the transition from marine to terrestrial. As we discussed earlier, we'll be doing prelay mattressing and then prelay grapnel runs. So essentially what that is on our route, we'll have a vessel that will precisely go along the route with a series of hooks that aren't meant to go deep, but they're really meant to pick up any sort of surface debris or organics that may interfere with our installation. We have the mobilization of vessels through the Lake Champlain locks, transpooling and cable transports from Karlskrona, Sweden, which is where the NKT factory is located. We have the axle vessel mobilizations and upgrades, which have been taking place in Greece. We have coordination and relocation of aids to navigation with the U.S. Coast Guard, and then additionally stakeholder engagement. So to touch on the photographs that you see, the top photograph is actually the fiber optic cable being transported in Lake Champlain following its exit from one of the locks. The fiber optic in Lake Champlain is actually going to be one continuous run. The bottom photo that you see there is a freighter that is at the time of this photo was transpooling cable from the factory at NKT.
Ladies and gentlemen, please stand by. We lost your audio for a minute. Sabrina, could you repeat the last couple of sentences?
Yeah, sure. I'm not sure where you lost me, so I'll try and pick it back up. But
just about 10 seconds there, Sabrina.
Oh, okay. Yeah, I just wanted to highlight the 2 photographs. I'm sorry about that. The top photograph, that's actually a cable barge transporting the fiber optic cable in Lake Champlain. That fiber optic cable that'll be installed in Lake Champlain is one continuous run, even though the HVDC cables will be installed in 8 different segments. The bottom photo is a freighter that's transpooling cable from the Karlskrona facility, NKT's Karlskrona facility. They'll be transporting the cable from Karlskrona directly to the United States. And then, as I started to say, Conger's transitional HTD, I think, is a relatively compelling transitional HTD, and you'll see why in a moment. But the photos that you see here, that blue rig, that's the actual HTD drill rig, and that's set up into what you'll see on the right-hand side, which are the pilot hole casings, and those casings go through from the surface through the groundwater into the side of rock, just to make sure that there is not any sort of integration with the drilling fluids that we use and the groundwater. Here's why this drill is compelling. So these are the plan and profiles here. It's roughly a 2,500-foot run that's down a 400-foot mountain under a golf course and under a park. It's probably, I can't speak for the terrestrial very intelligently, but it's probably one of the more complex drills that we have on the project, and it's certainly the most complex drill that we have transitioning from water to land. And then the last photo I have, this was from our installation campaign. This is deep ocean, transiting in front of the Cuomo, mattresses on deck. And with that, I'll pass it over to Michael Main, who is our Director of Engineering Services.
Thanks very much, Sabrina. Again, this is Michael Main. So we're going to talk a little bit about our terrestrial scope. I'm going to talk to you on this slide. I'm going to hand it over to Steve, and I'll see you all again in a couple of slides. But just to kick it off here, I wanted to talk about some very high-level metrics that I thought everyone here would find very useful. So we've got 108 miles of trench installation on the program. We also have 149 horizontal directional drills, or HDDs as we call them. Each boring operation, each HDD operation location really has 2 bores, one for each cable. Route miles, we've got, so with 149 HDDs, we've got about 38 route miles, but all in all, we've got about 75 bore miles. That's a considerable amount of HDDing that we're doing. We've got 2 jack and bores on the program. And then our splices. So obviously the cable comes in reels, in smaller segments, smaller pieces. So we've got 281 splice locations, and each of those splice locations has 2 splicing, two splices for each of the HVDC cables. Our splice distance, depending on just what's on the ground, environmental concerns, underground utilities, the distance between splices could range anywhere from 1,000 to approximately 6,100 linear feet. With an average of 3,200 linear feet. And the other item that I thought was very appropriate just to share with everyone here, most of our construction takes place on various rights-of-way, roadway rights-of-way and also railroad rights-of-way. And as you can imagine, the easiest way to get on a railroad right-of-way is to get to an intersection and then traverse the railroad. And oftentimes, that's really not the best thing for us to be doing. It's probably not the safest way or the most efficient way. So as part of the project, we are also working with many different folks to secure access roads. So for this particular project, we're constructing over 538,000 linear feet of access roads, which I think is just a really interesting metric when you have a look at it. So I'm going to hand it over to Stephen Rutke, and I'll speak to you all again in a few slides. Thank you.
Thank you, Michael. Hi, everyone. Stephen Rutke, Vice President of Project Services, and I've been heavily involved in the terrestrial part of the construction. As Bob pointed out in his illustration at the onset, we have to jump out of Lake Champlain up in Washington County and make our way a considerable distance through 5 counties back into the upper Hudson River. And in doing so, there's an enormous amount of coordination required. This slide walks us through some of that. As Michael mentioned, we use railroad rights-of-way as one of our primary corridors on the land. We work primarily with CPKC Railroad north of the Mohawk River and CSX Railroad south. We are using utility rights-of-way owned by National Grid in the northern part of the project and Central Hudson Gas and Electric in the Albany and Greene County areas of New York State. Orange and Rockland Utilities, which is in Rockland County for our purposes, requires extensive involvement as we use Route 9W as the corridor for that area where we jump around the Atlantic sturgeon spawning ground. We make use of DOT highways in Region 1, Route 22, that's in Washington County, and in Region 8, Rockland County, and have coordinated extensively with those agencies. Co-located infrastructure coordination is massive on the terrestrial side. There's about 4,000 documented individual interactions among probably 30 different private utility owners and a number of public utility owners and all varieties. We have parallel co-locations, crossings over and under adjacent overhead utilities, electric distribution, transmission, et cetera, to work with. The project has been very much a personal engagement in terms of working closely with local governments. We have individual agreements with 28 towns, 11 villages, 5 cities, and 6 counties in the categories of crossings and road use agreements for our crossings of roadways, our use for access road connections, our crossings of municipal utilities, and so on. And of course, a large amount of environmental coordination for streams, wetlands, endangered species, finding windows to clear trees that are outside of bat habitat restrictions was a major schedule player for us. And just to point out, the terrestrial part of the work does include a lot of water coordination. We have HDDs under the Mohawk River for considerable distance, and as Bob mentioned, under the East River for considerable distance. In general, the utility installation on land, we have primarily trenching as our preferred method, but as Michael pointed out, a lot of horizontal directional drilling. So the work steps for utility trenching are not unremarkable, but the sequence listed here shows how we normally go about our business, trying to get approval to clear trees and build access roads to access some of these relatively remote locations, installing erosion and sediment controls, usually in concert with a stormwater pollution prevention plan that's under a New York State DEC speedies permit. Mobilize our equipment. We primarily work on installing our splice vaults first in locations that have splice vaults. Properly locating all utilities. There's quality level B effort preceding the work, but also individual exposure and test holes at all cross utilities along the way. Our excavation process, the team calls it DLB, dig, lay, backfill. So excavating the trench primarily with a conventional backhoe, laying our cables, and backfilling with different materials, which we'll get to in a second. Our utility, our CHP, HVDC cables, which are 5-inch diameters apiece, are enclosed in 8-inch conduits, typically PVC. And our primary backfill material is fluidized thermal backfill, which you'll hear us call FTB, which is a low-strength material with self-compacting and has specific thermal properties that we specified. We do include warning tape above our backfill. We are carefully recording all of our measurements, all of our locations for well-curated as-built plans. Once the cables are all in the ground and backfilled, the conduits, the cable pulling operation happens from the surface, and the splicings happen at each vault or splice pit location. And ultimately, we restore the surface either to a vegetative state or restoring pavements, various pavement sections, depending on the jurisdiction. So to drill in a little further as to what our trench looks like, on the left, we have an engineering plan drawing representation of a typical, this says railroad right-of-way trench. And on the right, we have our public meeting rendering of same. For our many public informational meetings, we publish these renderings at life size so that the public could appreciate the relatively modest size of our important facility. But what we have here is our two 8-inch conduits and another conduit carrying a fiber optic communications cable. The trench in non-roadway installation is almost entirely backfilled with FTB and then capped with topsoil or suitable in situ soil, and then we reestablish vegetation on the top. By the way, because we are using FTB, we do have a lot of material import and a lot of material export. So the export and the finding a proper disposal location for the surplus material was another key project challenge. Very similar here on the next slide, but an in-roadway installation. In New York State jurisdiction, most of the towns and villages and counties defer to New York State specifications, which have a 5 feet minimum depth of burial under a roadway. This particular detail shows 6 feet, which is the DOT Region 8 requirement for Rockland County. And all of our roadway sections include something unique, which is a 18-inch thick rigid concrete duct bank enclosing our conduits. From there, it's the same FTB backfill and then the pavement restoration. Now I'll hand it back to Michael.
Thanks, Steve. So we're going to go through a few slides here. We brought with us some photos that we thought everyone find very interesting. So I'm going to just walk through them. So on the left-hand side here, we've got an HDD site. So you can see the drill rig off to the right center of the photo with the American flag on the top of it. And then you can see the bore apparatus, the drill head and the casing sticking off of it. You can see the HDD control booth, which is where the rig itself is operated from, the blue booth on the right-hand side of that photo. The middle photo, you can see our trenching operation with the temporary shoring installed. And off to the right, you can see the folks working in the fields backfilling the trench and moving down the roadway. So as Steve mentioned earlier, we do the trenching or we do an HDD, and then one of the later steps that we take is pulling cable and the splicing. So I've oriented these photos on this slide so that you can see on the left-hand side is the cable, the pulling rig or apparatus. And if you were to walk further down the road, on the left-hand side of the road, same side of the road, you would see the cable reel, which feeds the cable into the conduit. So these are oriented just as you'd see them on the roadway. But what really, the photo on the right really doesn't do that rig a justice. So we've had another photo inserted on the next slide here. And as you can see, is the individual standing on the top of the rig there. I mean, these reels are rather impressive in size. So I wanted to share that photo with you all. Thought it was pretty neat. So we've been talking about really all the construction operations for most of our presentation here. Some of what you don't see are what we call our laydown areas. This laydown area here in particular is up north, near Whitehall, New York, in Washington County. This is what we call our Ryder Road laydown area. So we have many different construction trailers, vehicles, heavy machinery, our cable reels, and also the crane that you can see in red off to the top right quarter of that photo, top right quadrant of that photo, excuse me. So this is our Ryder Road laydown yard. And another laydown yard that we have is further south down in Rockland County along the shore of the Hudson River on the west side of the river. This is our Tompkins Cove laydown yard. Similar things stored in this laydown yard, trailers, etc. One thing that we've done in this particular laydown yard is actually fabricate many of our concrete mattresses. So we thought that was another interesting thing to share with you all. So on this slide, we have more trenching operations on the top left, and bottom left, we're showing some drilling operations that we do in front of the trench to alleviate some of the challenges that we have in terms of trenching through rock. Middle and right photos are more trenching operations. And so you can see the cable on the rack in the bottom of the trench there, and you can also see the backfilling of that trench on the right-hand side. We did speak about splicing quite a bit. So this photo on the left here really shows you, the size of that splice vault from the inside. It's just a really interesting perspective, and we thought you all would find that interesting. The two photos on the right, really, we wanted to just demonstrate here. I mean, obviously, there's foul weather conditions where it would not be safe to work. But if conditions are safe enough to work, we do sometimes end up working during not the most optimal weather conditions, and we thought it was just something that we needed to share here. Finally, in terms of our overall progress on the terrestrial side, we're pretty much 95+% done with design. We're just closing out some last-minute feedback, comments from regulators, third-party stakeholders that we work with, and landowners. We've talked about the EM&CP process that we have with the New York State Department of Public Service. We've received notices to proceed on 14 of our 15 terrestrial segments. To date, a little more than half of the total cable that will be placed into the ground has been delivered. It's currently in our possession. It's in our laydown yards or in our possession. And one of the most challenging HDDs that we have on the program is down in Randall's Island. And so I wanted to mention that here. It's approximately a 1 mile long HDD, so there's two bores. Each of them are 1 mile long under the East River from Randall's Island over to Astoria. We had to work pretty extensively with New York City Parks to have everyone on the same page in terms of understanding what that operation was going to include. We recently received our construction permit from New York City Parks in March of this year. And our construction team is working to build the platforms that the HDD will be launched from. And so these are the three photos here. The first one on the left is looking west away from the HDD. The middle one is an overview, kind of like a stepping back view of the HDD platform looking over toward Astoria, where the HDD will be launched from. And then finally, the one on the bottom right there is a closer view of the location that the HDD will actually take off from on Randall's Island. So that really puts everything together for the terrestrial portion of our presentation, and I'm going to hand it back over to Bob Harrison, who's going to talk a bit about our converter station. Bob?
Thank you, Michael. Sorry, I skipped a shot here. So our converter station is located in Astoria, New York. Very interesting story. It's the former site of a number 6 fuel oil storage facility that I think it stored about 10 million gallons of number 6 fuel oil, which, as most of you know, is probably one of the most polluting of fuel oils that can no longer be burned in New York City. So we purchased the property. We commenced demolition work in August of 22. We completed site remediation in September of 23 and jumped right into pouring foundations and steel erection for the converter hall. So what you see there on the far right is as recently as last week. You can see where we stand there with the converter station building in the background on the right and the AC yard in the foreground in front of you. So that's a really, really great story to take a number 6 fuel oil farm and turn it into a source of renewable energy for New York City. And then the last shot I have is that's the artist's rendering of what it's going to look like when it's finished in Astoria there. You see it in the foreground. I thought that was a really cool shot with the New York skyline in the background. So thank you for your attention today. And with that, I'd like to turn it back to Mike Beeler.
Well, I would say that you had a lot of very cool shots in that. This is a fascinating project, and you had so many good pictures in there. So we've got some great questions from the audience, and we'll get right into those between now and the top of the hour. I'm going to start off with a question that you had a slide on there where you had Kiewit. What was Kiewit's role in this? And I want to talk a little bit about some of the engineering that went into this, some of the technical engineering, and maybe even some of the analysis of how did you design the fluidized thermal backfill? What kind of thermal characteristics did that FTB have to have? So what was Kiewit's role, and then how did you arrive at your FTB?
So Kiewit is our terrestrial contractor, EPC contractor. So they have the engineer of record role to design the trench system. And then to address your question is we did very extensive soil borings along the entire route to determine what the existing thermal resistivity was of the soil. And then NKT, who is our cable manufacturer, came up with what they call cookbooks, which are basically trench configurations based on the existing row values of the surrounding soil and the row values of everything that's going to be put on top of the conduits. And basically, the manufacturer will specify based on depth how far apart the conduits need to be in order to properly dissipate the heat based on the row values of all the surrounding materials.
Okay, so you had manufacturers' input on that with the cable spacing and the depth below grade.
Absolutely.
And such. Okay, great. There was a question in here about splices. You showed the big splice boxes. I think somebody was asking how big the splice box was, and then do you have to compensate for any losses in the splices? That's a question from the audience. And talk about the splices that are placed. That's a second question from the audience. So talk a little bit about the splices and the size of the splice boxes, if you will.
So I'd rather not go into the exact dimensions of the splicing locations because there are some design elements there that drove that I'm not able to share with you at this time. What I will tell you is that, regarding the losses, in our contracts we have guaranteed losses. So based on the design, between the losses from the cable lengths and the splices was all taken into account when developing those guaranteed losses. And then
Okay.
in terms of what drove the location of the splices, a lot of it had to do with the fact that we wanted to maximize the cable length that could be transported over the road, and then that is offset by local conditions that may or may not allow you to do that. So our cable lengths run anywhere from, call it 600 meters to 2,000 meters between splice locations.
Wow, impressive. There's a couple questions in here about the length and the depth of the directional drills that you have. So, so what was the directional drill length and depth into the golf course that you showed? And then how deep are those 1 mile HDDs? Two questions from the audience.
So I think, so Sabrina will take the first question, and I think either Steve or Michael will take the second.
Okay.
Yeah, so the image that I showed, it was 2,500 feet, and then the depth from the highest point to the lowest point of the drill is roughly 390 feet, so almost 400 feet.
And what were the diameters of the drills? And then with the size of the conduit that you ended up pulling back that you'd pull the cable through?
So the conduit is 12 inches.
Okay. Great. Okay. Next question.
Yeah, and let me, Bob asked me to answer the other part about the 1 mile bore which is the one under the East River. I don't have the actual depth there, but I believe it's on the order of 30 feet below the bottom of the riverbed there. So it's not among our deeper HDDs. It was the length there that was the challenge. Is by far nearly double the longest HDD that we have. On the terrestrial side, there's HDDs as shallow as 20 feet and as deep as about 180 feet.
Okay. Somebody asked a question, I think you covered it, but who's the manufacturer of the HVDC cable?
That would be NKT.
NKT. Okay. Early on, you said that Hydro-Quebec is going to be doing the O&M on the Canadian side, and CHPE LLC is going to do the O&M on the U.S. side. What kind of O&M work do you anticipate? And the question here from the audience is about the what kind of inspection is going to be done on the cable? I mean, like commissioning of the cable. Will you have anything where you go in to establish the condition of the cable right after the installation, so you've kind of benchmarked where you're at to start with?
So yeah, that's let me unpack that into there's a couple of questions in there.
Okay, thank you.
As far as the cable goes, we will have very rigorous documentation of knowing exactly where the cable is located in terms of as-built drawings. The cable will be equipped with a DTS and a DAS system, so we'll be able to detect temperature anomalies along the route, as well as acoustic signatures should somebody be banging a backhoe in the neighborhood of the cable. Obviously, we'll be participating in the one call and the 811 systems, call before you dig. So we will go out and mark out our line. Our manholes, when we're in the public streets, do indicate that it's CHPE and it's 400 kV, which I think was another question I saw in the questions. The DC is 400 kilovolts. And then there will be periodic inspections. For instance, you got to make sure you don't have any oak trees growing over your cable trenches. So vegetation management is a big issue. That's why we're primarily in railroad right of way and under roadways. basically not have to worry about that. But we will do periodic inspections of both the terrestrial route and the submarine route every couple of years. We'll do a burial assessment in the waterways to make sure that we don't have any uncovering of the buried cable. And then lastly, the converter station typically requires one outage per year for maintenance purposes. And we will coordinate that with our partners at Hydro-Quebec so that both converter stations will be out at the same time for maintenance, and which will minimize the downtime of the line.
Fascinating. We're almost to the top of the hour, and I want to give you guys a moment to give a recap, each of you. But let me ask two more quick questions. One, comment, if you would, on the railroad right-of-way. One of the real opportunities in the industry these days is to go into, put transmission lines into existing transportation corridors like freeways, highways, and railroads. How did your railroad right-of-way opportunity develop? Was that fairly straightforward for you?
So back in the development time, it looked like a very clean way to do things. As they say, the devil is in the details. And as we got into the detailed design, it turns out that the railroads that Steve referred to before, the railroad rights of way we're in were acquired by these Tier 1 railroads, and these railroads have been around for over 100 years, and the railroad rights of way are anything but uniform, which presented some very interesting challenges to overcome. It's not like the right of way is 30 feet off the tracks on each side for an infinite distance. That's just not the case.
Right.
And I think that was kind of the biggest surprise as we got into the detailed design, that it wasn't quite what we thought.
Okay.
Steve,
Sabrina, I wanted to ask a question, and I'm going to start with you just to wrap up and say your salutations, your thank yous. But there was a question or two about mattresses too. So thanks for the explanations on mattresses, and somebody wanted to know about how many mattresses were used. But give us some concluding remarks, Sabrina, and then Michael will come to you, and Steve, and then Bob.
Yeah, so as far as mattresses are concerned, so we do have discrete locations where there's existing infrastructure where we know mattresses will be installed. But as far as the total number of mattresses, that's difficult to predict. We do have a permitted condition that requires us where any location where we don't meet the required burial depth per the permit and the certificate, we are required to cover our infrastructure with the mattress. And that's both to protect our infrastructure and for, the safety of navigation for the vessels. Like I mentioned previously, it is an industry standard practice that we are using, and we do intend to minimize the number of mattresses to the greatest extent practicable, because number one, lowering the cable to the depth required dramatically reduces the risk to us, and number two, mattresses are expensive, and they're expensive to install and maintain. So it's certainly not ideal from our perspective for installation to use mattresses as a
good. Yeah, thank you very much. And a concluding thought, Sabrina.
Yep. Really appreciate the opportunity. I know from my perspective, I've worked my entire career in the United States government in one capacity or another, and they convinced me to leave that work to do this. We believe in the work that we're doing, and we're really excited to have the opportunity to build this project and power New York City. And with that, I'll pass it to Mike.
Yeah, it's fascinating. Absolutely. Michael Main, concluding thought.
Thanks, Mike. I very much appreciate everyone's time, and so glad to be here. I've been working on the development of this project personally since about 2012. So, being involved that long and being in the throes day to day of detailed design, and our engineering construction efforts are great, and it's great to be able to come here and share all of this great stuff with everyone. So thank you, everyone. Thanks, Mike.
You did a great job. Thank you. Stephen Rutke, a final word?
Yes, thank you. I really appreciated that question about the challenges in the railroad right away. In the terrestrial side, it's been amazing how complicated it is to fit a 30-inch wide trench absolutely anywhere, with all the constraints from buildings to wetlands to easements to other utilities under the sun. But a great project. I really appreciate everyone's time today. I'm glad to be involved. I live within about a quarter mile of where the route passes through in Saratoga County. So thank you so much for your time.
Bob Harrison, what a visionary project. Congratulations. It's very exciting. A concluding thought from you, sir.
Yeah, thanks. And this is truly a transformative project for two reasons. Number one is that it helps New York State meet its Climate Leadership and Community Protection Act goals of renewable energy for New York City. And also from a reliability standpoint, the New York Independent System Operator has indicated that if CHP is not operational in May of 2026, that the reserve margins of available power will drop below acceptable levels. So there's a lot of pressure on us to get this project done on time. So thank you, everybody, for your attention.
Thank you very much. And on behalf of the Power Delivery Intelligence Initiative, we are thrilled to bring you this major underground and submarine project program that is going to impact that whole region of the country. So thanks again to the team from TDI. And Rod Walton, back to you.
Yeah, thank you. Thank you very much, Mike. I hope everybody can hear me, but that is fascinating, and it's amazing to think that a project that has, been in the works for 14 plus years now is within hopefully 2 years of the finish line to be operational. And it's amazing what you guys have achieved so far and what you're doing. So congratulations on that. And that concludes today's live presentation. On behalf of T&D World, I'd like to thank our panelists for their wonderful discussion today on the Champlain Hudson Power Express, a renewable energy solution for New York City. And to our webinar sponsors, Power Delivery Intelligence Initiative and Transmission Developers, Inc. Great job by Bob Harrison, Sabrina Taylor, Michael Main, and Stephen Rutke, all of TDI, and our moderator, Mike Beeler of the Power Delivery Intelligence Initiative. This is a project for the ages, and surely a sign of things to come as we try to remake a power grid to satisfy the ambitious goals of a clean energy future. Let me end by also appreciating our attendees for joining part of this and to offer your great questions. We'll learn from each other. I'm Rod Walton. Have a great day, everyone, and hope to see you on a future webinar. Goodbye for now.